The following example is an important idea needed to verify the logically equivalent statements of the invertible matrix theorem. Now, we won't be seeing this theorem until section 2.3, but we're already beginning to establish the important concepts behind this theorem and to make the necessary connections needed for the proof. So here we go, get excited. In this example, we are going to suppose that matrix C times matrix A equals the n by n identity matrix. And this is where matrix A and matrix C are size-appropriate matrices. Now, we are asked to show that the homogeneous equation has only the trivial solution under these assumptions. Afterwards, we want to explain why matrix A cannot have more columns than rows. So here we go. We want to begin by supposing that matrix C times matrix A is equal to I sub n. And this is such that I sub n is that n by n identity matrix, and that matrix A and matrix C are size appropriate. So that's our initial assumption. And now, to begin, let's just consider the homogeneous equation. So we have matrix A multiplied by vector x is equal to the 0 vector. And let's keep our goal in mind. We want to show that the homogeneous equation has only the trivial solution. So we want vector x to equal the 0 vector. So keeping our assumption in mind, let's begin by left-hand multiplying by this size-appropriate matrix C. So we have matrix C multiplied by matrix A times vector x is equal to matrix C multiplied by the 0 vector. Now, by properties of matrix vector multiplication, we can reorder the terms on the left-hand side and say that this is matrix C times matrix A multiplied by vector x. And this is equal to, on the right-hand side, we know that a matrix times the 0 vector must be equal to the 0 vector. Now, notice here on the left that we have matrix C times matrix A. Now, under the given assumptions, this is equal to the n by n identity matrix multiplied by vector x is equal to the 0 vector. And again, by properties of matrix vector multiplication, we know that a vector multiplied by the identity matrix is just that vector, leaving us with the 0 vector, or in other words, the trivial solution. Woo! And we can make our final conclusions and say that therefore, if matrix C multiplied by matrix A equals the n by n identity matrix, then the homogeneous equation matrix A times vector x equals the 0 vector has only the trivial solution. Beautiful. So, now that we have verified the first part of this statement, or this question, we want to go ahead and think about the second part of our question. And that's asking us to explain why matrix A cannot have more columns than rows. So let's begin by simply thinking about the conclusion we just made. Well, we can say that since the homogeneous equation, matrix A times vector x equals the 0 vector, has only the trivial solution, what does this tell us about the matrix equation? Well, since the homogeneous equation has only the trivial solution, then by definition, the columns of matrix A are linearly independent. So the column vectors of matrix A are linearly independent by definition. So if the columns of matrix A are linearly independent, then this lets us know that no free variables exist. So if no free variables exist, let's give ourselves a little bit more room. If no free variables exist, this lets us know that the number of unknowns in our system must be less than or equal to the number of equations in this linear system. So what's another way to refer to the number of unknowns and the number of equations? So this is equivalent to saying that therefore the number of unknowns or number of columns of matrix A must be less than or equal to the number of equations or number of rows of matrix A. So therefore, we have shown why if the homogeneous equation has only the trivial solution, then matrix A cannot have more columns than rows because the columns of matrix A are linearly independent. So we want to make sure that there are no free variables. So there you have it. This is the first important connection that we need for the invertible matrix theorem.